distributed index in Lucene. For large, here you can see document partitioning. For large corpus like web documents, the index is typically distributed across multiple machines. There are two models of distribution: term partitioning and document partitioning. In document partitioning, documents are randomly spread across different partitions where the index is built. In term partitioning, the terms are spread across different partitions. We will discuss the document partitioning as it's the most commonly used. Distributed index provided by other technologies that is built on Lucene, such as Elasticsearch. A typical setting is as follows. In this setting, machines are organized as columns and rows. Each column represents a partition of documents, while each row represents a replica of whole corpus. During document indexing, first row of the machine is randomly selected and will be allocated for building the index. When the new document is crawled, a column machine from the selected row is randomly picked to host the document. The document will be sent to this machine where the index is being built. Updated index will be later propagated to other rows of replicas. During document retrieval, the first row of the replica machine is selected. The client query will then broadcast to the every column machine of the selected row. Each machine will perform the search on its local index and return the top M elements to the query processor, which will consolidate the result before sending back to the client. Notice that k divided p less than m less than k, where k is the top k documents the client expects and p is the number of columns of the machine. Notice that m is the parameter that needed to be turned. One caveat of this distributed index is that as the posting list is split horizontally across partitions, we lost the global view of IDF value, without which the machine is unable to calculate TF-IDF score. There are two ways to mitigate that. Do nothing. Here we assume the document is evenly spread across different partitions to the local IDF represent a good ratio of the actual IDF. 2 extra round trip. In the first round, query is broadcast to every column of the return to its local IDF. The query processor will collected the IDF response and compute the sum of the IDF. The second round, it broadcasts the query along with the IDF sum to each column of the machine, which will compute the local score based on the sum. Here you can see term partitioning, machine T1, term 1, term 2, machine T2, term 3, term 4, term 5. And here you can see machine D1, doc 1, doc 2. Here machine D2, this is document partitioning. Machine D2, doc 3, doc 4, doc 5. Here machine D3, doc 6, doc 7. This is about distributed index here. And here you can see a client query and pick a random row and scatter together, and this is connected to partition 1 replica, partition 2 replica, partition 3 replica. Here you can see the row 1 and row 2. Here you can see the crawler randomly pick one, and here you can see the indices, and here you can see the inverted index. Here this inverted index connected to this one, and here this inverted index is connected to this one of the row 1, and this here the partition 3, the inverted index is connected to this one. Now this is the end of my presentation. Thank you very much for watching it.